Good afternoon. Good afternoon. Okay, wait. Okay. Wait, okay, I'm gonna do it this way. Good afternoon, Alyssa. Good afternoon, Andrew. Good afternoon, Charlie. I think you can hear me, right? Yes. Okay. Good afternoon, Stephanie. Good afternoon, Vivian. Good afternoon, Jaylyn. Good afternoon and hello, she. And hi, Michaela. And good afternoon, Catherine, with an I. Good afternoon, Lakshmi, with a me. Get it? I, me. Okay. Good afternoon, Gabriella. I might bring a stuffed lobster this time. I'm not sure. Okay. Hello, Warda. Good afternoon, Celine. Good afternoon, Syed. Hey, everyone, and good afternoon, Rachel. Hello, Shagupta. Thank you, Lakshmi. Wow. All right. You just got 50,000 points of class participation. Cool. And for politeness and for lying. Okay, wait. And also, good afternoon, she. Good afternoon, Gabriella. I'm doing the video thing now. Totally not. What do you mean? Who's him? How am I already being get? Oh, yeah. Okay, that probably was a guy. But it was a polite guy. That's different. That's called a polite fiction. But good afternoon, she. Good afternoon, Gabriella. Good afternoon, Shagupta. Good afternoon, Rachel. Good afternoon, Alyssa. Good afternoon, Michaela. Good afternoon, Jaylyn. That's the visual acknowledgement. Wait. See, now you're offending Lakshmi. Like, come on. It's one thing to offend me. It's one thing to like make me all awkward, but my parents did that already 51 years ago. Now you're actually dumping on Lakshmi. She's been like a force of innocent goodness and brilliance in this class for 2 semesters, and now we're like pooping on Lakshmi. Holy moly. Wait. Thank you. Talk about gaslighting. That's some compensation there, but thank you. Okay. Yeah. Whoa. And Rachel's involved in it now. See what's happening? This is what we do. This is how the family becomes dysfunctional. Well, yowza. All right, wait, I'm gonna get sucked in. I'm not the one with an exam coming up. Well, yes, I actually am, but you know that expression, it hurts you more than it hurts me. That's what I always feel like when I'm giving you exams, even though I know it's a total lie. And I know it's like the most offensive expression in the world, because I know that when you take an exam, it actually hurts you more than me. I do understand that, but it does hurt me. Okay, wait, who would I just miss in the chat? So wait, Rachel, get out of this kit. Whoa. Oh, Rachel totally took the high road with that. She totally just pulled a like gospel according to Rachel on you. Whoa, yeah. Wow. She's just like, now everybody else has to feel bad about their own abuse. She just like turned that into an offensive foul. Not offensive, but like as in basketball. Okay, I'm gonna shut up before I make this worse for everybody. We're gonna do some physics here, but yes, I love this class. Have I mentioned? And yes, I honestly, okay, I'll admit, okay, I'm gonna turn the page to get us rolling here. I'm turning the page. You'll even notice if you're in the part of this group that like actually want, I don't think I have to tell you that if there's 2 words that are really risky and dangerous ever to say to me, it's keep talking. Like that is, is that a suicide sentence for anybody to say? But I will. I'll take you up on that. I will keep talking. What was I going to say? For those of you who want to do physics, there might be, I don't know. I feel like there might be. So, okay. So she, what I'm saying here, this is a compliment, is you can get ahead of everybody else by realizing that I'm going to be asking everybody to turn to page 8 of their practice exam. I totally just singled someone out. That's so unfair, but it was a compliment. I mean that she is here to do physics. And I know that for an absolute fact. I've done the research, but yeah, I'm saying, turn to page 8 of your practice exam. We're going to go over problem 5 of the practice exam in the spirit of, again, this is in the spirit of we're trying to practice for the exam. And people are coming, and I'm trying to give you solutions to it. I'm not saying that I won't also post some solutions, like I will. I'm not saying that I'm lazy. I am. I'm just not saying it. But part of how we're dealing with this exam and this practice is just like to go over some stuff during the class. And one thing I'd like to go, so I also want to make it clear what someone's here in the waiting room. Sorry. I never do the waiting room correctly. Oh, more. Okay. I am saying my starting agenda item today, if we get to nothing else, is I want to kind of look at, I'm going out of order on purpose. I'm not just going to like walk through this whole practice exam. Like we would never get through the whole thing if I just linearly do it. I'm picking and choosing aspects that I think are worthy of your attention like now. So I'm picking that we're going to go to page 5, the question 8. I'm sorry, I mean page 8, the problem 5. In part, we're going there because that is something that I appended. Like why am I explaining this? The point is you might not have even noticed that it's there. So I want to make sure that you know that it's there. And I'm intentionally jumping to that page. No problem. Sorry. Yeah. No, oh, thank you. No, totally. Direct chat person. No problem. Thank you. We're going to turn, as it says in red here, we're going to turn to page 8 of the practice exam, of the most recent installment of the practice exam, which I think was the second installment. It came out while you guys were in lab last Tuesday. And it included that last page that wasn't there before. We're going to go to it now, or when I stop talking, we're going to go to it now. It's definitely important. Also, to be clear, it's not a coincidence that by jumping to that page, I'm jumping sort of back to a continuation of the most recent material that we were doing right before I posted the practice exam. Like that's on purpose. Like I want you to really know your fundamentals. I think if you're studying for this or practicing for this, it is good to study and practice in order. Like the more you know the fundamentals, the more everything builds on them. But then let's also sandwich it. Let's also see like where it all ends up. The material thus far is the wave equation as presented right here on the board and as presented in the last page. So that's where I'm going to go now. If I stop talking about it, please do ask me questions. I am going to say that whatever we say about this question right here and now in this class, like that counts as my solution to it. Like what whether you write it down or it's in the PDF that I post, like I won't like, and then I'm going to prioritize whatever I still want to publish for you or give you as solutions. I'm first going to prioritize aspects of the exam we have not explicitly talked about. Like, okay, you're not necessarily going to get 2 copies of this solution. In other words, okay. There's one of the. I still owe you stuff. As always, again, just to remind you, the exam itself will be posted like Thursday evening, and then we'll be due back next Monday. So we have today to talk about it. We have Wednesday. This also means, like, I'm here with my agenda item, which is page 5. I think you should know it. Sorry, I keep saying that. Page 8. But if I ever stop yapping about it and just do it, if I get through it quickly, then really I would encourage you guys to tell me what you want to see next, what you want to, and or please, if you have questions about this exam at all, even if they're not about page 8, please put them in the chat at any time. If they're about some other page, I may wait to answer them, but please put them in the chat. If you have been studying, if you have been practicing with this practice exam, like if you have anything, please put in the chat. If nothing else, I will use what I see in the chat to inform how I approach our next class on Wednesday, which kind of is the last class we'll have before this exam. Okay, so please don't be, and you can also text me and stuff like that, but don't be shy about putting a question in the chat, even if I don't get to it right now. And the only one question that would not be worth your time, don't waste your own time to just put in the chat, can you please post solutions to the other questions? Like, I'm going to try, I will. And if I fail, but it won't be because you didn't put it in the chat. Like, okay, but specific things, if you're like part B of this, of that, put it in the chat for real, even if I don't get to it now. Okay. Okay, I'll shut up. But we're all sort of just about trying to get our heads together for this exam. And also, if you have procedural questions about the exam, procedural questions, especially like if you didn't have me last semester or something, like, again, even if you think maybe you were supposed to know and I was supposed to answer, and if you were paying attention, you would know, that might be true, then fine. If you're a little embarrassed, put in the direct chat or whatever, but better to be safe than sorry now about the rules, of the exam, or like what would constitute cheating or whatnot. Or I'm going to put right now, in fact, one last time before I start, because I see this always makes me nervous, all this exam stuff. One more time, just in case, I'm putting my cell phone number in the chat right now. the rule of using my cell or, texting me, and some of you hopefully have like already proved this to yourself. The rule is you can text me a lot and you can text me at any time. The shorter, more concise your question is, or the more concisely I can answer it, the more delighted I will be to answer lots of them. Like if you can make a question that takes you longer to write than it would take me to answer, then keep them coming. And with text, I'm pretty fast. If I don't get you right away, it means I'm teaching or flying or something, and it'll be like in an hour. Like really, really, I like small frequent. I'm better at small frequent than big infrequent. Okay. So any question about the exam, especially rules or expectations, just okay. Okay. All right. So therefore, having said that, I'm going to turn to page 8. So the last thing, I'm just going to basically like walk through the last question. Also, if you think it's too easy or not worth your time, you can tell me that in that chat too, and I'll try to speed up. But okay, so we are at. Oh, in fact, okay, I'm going to screen share for a second so you see, so we're definitely on the same page. Sorry. I'm going to change screen. This is just so we all know what we're doing. Okay, so I'm here. Like this is what I'm going over right now. Again, this is the last page of the updated version of your practice exam. Okay, you might not have seen it if you only downloaded the first installment, but it's there. Okay, so this is what I'm talking about. I hope you have it in front of you because I'm going to switch screens again in a second. Let me see. Okay. Yeah, I'm going to now. Okay, if everybody can see that, I'm going to switch screens. Sorry. Could I tell if you? Oh, can I just get any kind of thumbs up or any affirmation that we're all together, that like it's cool if I now switch off this and go to the whiteboard? Can I just get any affirmation that's a yes? Okay, cool. Okay. Thank you. Awesome. Oh, lobster. Okay, great. Thank you. I love this class so much. Did I say that? Oh, I'm going to start yodeling again and I have to move to Walmart. Okay, great. Thank you. So I'm going to switch. Okay. Oh, that did not do that, did it? Okay, this is what we're doing. And this is totally an exploration. The way to do this is to know, well, the thing that I wrote, the thing you have to know for this, first of all, is the wave equation, which is like essentially written right there and was written at the front of the notes, but there's different ways to write the wave equation. That kind of like one way to write the wave equation is this. And don't be fooled. Oh my God, I don't think I would intentionally do this to you in the exam, but please know for your future life, because the wave equation comes up so much, you should not be thrown or fooled. If you ever see someone write it like this, for example, like there's many ways to skin a cat and all of them are disgusting. But I mean, there's many, like notice just the subtle thing that I just did. I don't want to dwell on it, but you should be clear in your mind that the way I just wrote it is equivalent, right? Like I divided both sides by v squared in effect, right? Like please be comfortable if you ever see it in that way, that should not bother you. But also notice like the v, right? So the wave equation says that at any given point in some one-dimensional medium, at any given point, the acceleration of that point back toward the equilibrium axis is directly proportional to the concavity of the medium at that point, right? Like that's literally what I think the wave equation is saying in English. But notice I use the phrase is directly proportional to the concavity at blah, blah, blah. That means is equal to the concavity times a constant, right? Like that's what is directly proportional means. It means is equal to a thing times a constant. The constant in this case apparently is v squared. V squared means the propagation speed squared. And where I ever got that, like that wasn't the first, at first we didn't know that. At first, when we derived the wave equation, we wrote it like as the following. Right? Like, so quick moment of review, refresh, whatever. When we first got the wave equation by taking two derivatives of that cosine function, in fact, I'm going to write that too. We originally, both from lab data and from our examination of, or our mental construction of a collection of identical phase staggered oscillators, right? Whether it was lab 3 or was considering a whole bunch of springs sitting next to each other along a horizontal axis. Either way, we came up with this cosine statement that was dependent on both time and horizontal space, right? We took two derivatives of that cosine statement and we got this differential equation that I'm looking at, this differential equation that I'm looking at. Like, again, this is review, refresh, whatever. Our first landing, our first moment of arrival at the wave equation, it was in this form. It's written at the bottom of my page. And it had an omega in it and a k in it. And that omega and the k came from the omega and the k in the y equals a cosine omega tk, right? Because we took two derivatives of that with respect to time. And we independently took two derivatives of it with respect to space. And then we like algebraically smashed them together. And we got this second order differential equation. Now, again, this was like, I don't know, 2 weeks ago or something like that. Then we said, oh my goodness, omega over k. Okay, that's functioning. That is behaving as just a constant of proportionality in this partial differential equation, but it has meaning. We say, like, at first we were just like, oh, that's a constant of proportionality. It's saying that concavity is directly proportional. It's saying that acceleration is directly proportional to concavity. But then we decided to unpack it and we said, well, what is that constant of proportionality? It is a constant, but does it physically signify anything? And it turned out that when we thought about it, we realized that omega over k, angular frequency over angular wave number, is the propagation speed of the wave. Now, I'm reminding you of all this before I even solve the problem. I'm reminding you of all this before we solve the problem, partly so that you're not thrown if equations are written in there's different ways to write different equations. You really want to understand the concept so that you're not like rigidly tied to one specific way of writing an equation. I'm saying that omega over k means the same thing as lambda over t, which means the same thing as lambda times f. Like however you slice it, what it means is meters over seconds. No matter how you write it, whether we write it as angular frequency over angular wave number, or we write it as wavelength over period, or we write it as wavelength times frequency, what we're saying is the amount of distance from one crest of the wave to the next divided by the amount of time from one crest of the wave to the next. No matter how we write it, we're saying the distance, the length of one cycle of the wave divided by the time for one cycle of the wave. So this is the speed of the wave. However we write it, omega over k, lambda over t, or lambda times f. Sidebar, get like, why do I keep writing in three different ways? Well, one, so that you're not thrown, so that you're comfortable with any of those three. But why are there three ways? Because just like there's three ways to measure the frequency of an oscillator in the first place, like just like we had omega, we have f, and we have t, and they all ultimately are conveying the same information. But there's three ways of sort of thinking about that information, really, because one, the first omega comes most directly from the math, whereas t is the most picturable, and then f mediates between the two. Same, what did I just do? Okay, same thing here. Omega over k is the most mathematically explicit, mathematically direct way to express the propagation speed of the wave. Lambda times f, like written all the way to the right side of the middle of the board, like omega over k is the most mathematically explicit and mathematically direct. It's like literally what pops out when we first derive the wave equation. Lambda times f, there's like, it's nowhere, and there's no lambda in our wave equation. There's no f in our wave equation, but lambda times f, quite honestly, is the most common, most sort of intuitive, most mentally picturable way to talk about the speed of a wave. Like honestly, in any other science course you ever take from here on, PChem, instrumental, or science courses in other areas, whenever they talk about the speed of a wave, they're 99% of the time, they're going to say that the speed of a wave is the wavelength times the frequency. I want you to see that that's not just a memorizer. That makes sense. That a wave speed would be a wavelength times the frequency is like saying distance over time for a wave. Okay, and to me, in a way, it's easiest. So the immediate. All right, you get my point. So speed can be written any of those ways. Okay, so now, so here's the background knowledge. If I were trying to solve, oh God, you know how noisy it is up here. I'm about to solve this problem on page 5. Really, on page 8. What I think I need to know to solve it is what I wrote right down. All these things that I just wrote here really would figure into step 3, GDP, of solving that problem. Like, you need to know this wave equation. You need to know that the constant of proportionality is v squared, and you need to know that v itself could be broken down into any one of these equivalences. So having said that, let me solve the problem. Fine. Let me put up the problem to myself. So in the problem, we're told, okay. Okay. Okay, right? Everybody's with me, right? So the question, the ultimate question is, I want to know the wavelength, given all of this. Okay. So what? So I think now for step. So I think the things that I need to know to do this. Okay, so in step 3 here, I'm writing down some fundamental principles and definitions that I think I need to understand this problem. I'm going to tell you right now, I'm writing down the wave equation so that right away I can understand even what that, they gave me d2y dt squared equals 900 times d2y dx squared. So first thing, I'm writing down the wave equation just as a declaration to myself, the student, and to you who's ever grading the exam, to say, okay, I know what's going on here. Like I'm saying right away, I understand that 900, that's functioning as a v squared in the wave equation, right? Then I'm reminding myself what v is. V can be broken down into omega and k, like I said a second ago. But now, what are omega and k? Angular frequency is cycles per time, but measured in radians, right? And angular wave number is cycles per space, measured in radians, right? Like literally that's what it is. Angular frequency is cycles per time, but just measured in angles, in radians rather than full cycles. And angular wave numbers, cycles per space, but measured in radians, in pieces of a circle, rather than pure cycles, right? So angular frequency is 2 pi over the period. Angular wave number k is 2 pi over lambda, right? Like these are pieces of general knowledge that I think I'm going to use to figure this out. So what I'm going to use here Okay, so let me pause for a second. I think that's the answer to part A. I'm going to admit or be explicit, like the only equation I actually use to figure that out is this one right here. That's the only equation that I actually explicitly use to do this part A. But I wrote a couple other equations down first to basically, I'm going to use them later, and to put perspective on the whole problem, and to help me understand what this k equals 2 pi over lambda actually means, or how it applies in the first place. But that I'm going to look in the chat for a second. I can't do two things at once. Okay, but that's what I think the answer is to the first question. Okay. Yeah, that's a very good question. I was wondering if someone, good question, direct chat person, like, so you'll notice, someone just asked in direct chat, very fair question. They wrote, how come I dropped the word cycle out of the units for wavelength? Very fair. And first thing, let me say that if you don't do that in your exam, if you left it as meters per cycle, I'd still give you full credit. Like there's actually nothing wrong with writing 62.8 meters per cycle. The two reasons, or maybe the three reasons I dropped the word cycle, like when an extra step is, number one, I think the actual exam explicitly asks, the actual exam says in meters, find the wavelength. Okay, and that's a very fair question because wavelength is traditionally measured in meters and it's telling you what units it wants your answer in. So partly in effort to be perfect, to literally answer the question as it's asked, partly that's why I dropped the cycles. Like in the very final analysis, like I look back at the question, like what is the question? Oh, it's find the wavelength in meters. Oh, the number of meters of this wavelength is 62.8. So partly I did it for that reason, to literally end up at what the question is asking. But again, this is a very fair question. I'm glad he or she is asking, or he or she or we, she. No, just kidding. Okay. But second of all, so that answers like why I wanted to. But then there's a question, well, why did I have the right to? Like just because I want to answer and be like what? Well, and the reason I have the right to, and the reason like this happened at all is what wavelength means. What it means is the number of meters that are in a given cycle. Okay, that's what it means. How many meters are in a cycle? But the truth is that a cycle is not an actual unit of MKS or SI or whatever. Like cycle is not an actual standardized unit. And there's a good reason for that. If you ever think about it, what standardized units are, and again, this can get very deep. In fact, I love the question. But my short answer though is if you ever think about what the standard units of measurement are, like meters, kilograms, and seconds, those are not just concepts, but they are definitive sizes, right? Like the whole point that we have a standard meter is not only that we all agree on like how we're going to go about measuring length, but we all agree on what like the size of our basic unit of length is. It is like this big, a meter, and same thing with a kilogram and a second. Well, a cycle is a concept and it's a thing that we're measuring, but there's no specific size of a cycle. There's not like one standardized, agreed upon size of a cycle. So in that, that's one of the, so cycle is not actually a unit. It's a concept. It's an instruction to us. It's saying when you measure wavelength, we're asking you for a certain length, and we're asking you for the length of a cycle. So it would be kind of like saying like, what's the height of a person in a Yaver-bound family? Well, like I measure all the people in my family and like take the average height of that. And my final answer, like I'd be doing all this work about the height of people in my family, but my final answer would be 5 feet, not 5 feet per person per family. You know what I mean? Like so I was doing all this work to figure out. So I'm tracking. I'm trying to be consistent. So I'm telling myself, look at the radians per the cycle, look at the meters per the cycle, and the cycles all carry through consistently. But in the final analysis, they're not actually a unit. I can get rid of them. The other reason though that that's a really good question is the truth of the matter is, and again, this is all a technicality in a way, like if you just left the cycles there in your final answer, I don't think I would take off points, but a wavelength is a size and it is measured in meters. It's almost our way of saying that at the end of the day, after you've been careful about consistently looking at cycles of a wave, we can still subject a wave to standardized formal ways of measuring. Like that's sort of the cool thing. We're saying in the end of the day, the size of a cycle is a certain kind of size. It can be compared to the size of a baseball or whatever else. It's a number of meters. Just for the record, and then I'm going to move on. But again, it's a great question. The truth of the matter is radians and degrees are the same thing. Radians are words that we track around, that we keep in our computations to remind us of what we're doing. We keep the word radian there as a placeholder to remind us that we're not talking about degrees, or B, that we're not talking about some other thing like kilograms. But a radian, well, is this comparable? A cycle doesn't have any definitive size, and a radian is a meter divided by a meter. A radian is a portion. What a radian is essentially a sixth of a cycle or of a circle. And we just said that cycles don't have any specific size. So radians don't honestly in the world have a specific size either. A radian is specifically a sixth of a circle, but a circle could be any size. So truthfully speaking, at the end of the day, radians fall out also, which is why they can cancel out at the end of a calculation, just like the cycles just did. Okay, longer answer than anybody wanted, but great question, honestly. Oh, we got, and what happened to, oh, weird. Okay, sorry. I have focus on, but I have special context pushing their way through because they're, what do you call it? Favorites. Okay. All right. Anyway, that was A. If there's any other questions in the chat, that was a, oh, there's more questions in the chat. I'm sorry. Okay. Oh, great. Oh, direct chat person. Thank you for acknowledging that I just said. So please put that in for class participation that you just closed the circle. Okay. There's other things, seriously, but now, oh, there's other things in the chat. And then can we write step? Can we write step one equation at the top of the page? We have to write it down. Wait, this is a great question about procedure. Okay, I'm going to read this out loud. Can we write step one equation given information at the top of the page, or would we have to write it down for question? Oh, I think I get it. Sorry. This is, let me read it out loud. Can we write step one, what I call the diagram and fact patterns, DFP, the equations and given information, right? Step one, I totally agree. Step one is the givens, usually including a diagram. The question here is, can we write it at the top of the page, or would we have to write it down? I think she or he is asking for each separate question in order to get credit, right? Like, since we're going to use the same given facts for each part of this, do we have to keep writing down the given facts in the diagram, or can we write it sort of once and then use that for the rest? Totally fair question. Very good question. And my answer is yes, you could totally just write it once at the top of the page. Absolutely, you can. If it applies to like everything on the page, sure. Ideally, maybe for each part, you could just write at the beginning, like put a little arrow or a little like, just a little like see above for facts or whatever. But yes, you definitely don't have to keep on writing it over. That's right. That's good. And the reason I like these questions is that it shows you guys care about this. Like, and you should. So good. So keep them coming. Okay. So that makes sense. Thank you. I meant to say, okay. Right. Okay, great. So thank you for the thank you. Thank you both direct chat people for, these are great questions. Please, I hope everybody sees. And please don't worry about, if you're ever thinking, Jesus, if I ask a question, it's going to slow him down even more. Like he has a hard enough time getting to the point without a question. That may be, like, if I were you, I'd be afraid of that too. But look, if I have a hard enough time getting to the point, think about it. I have a hard enough time getting to the point. If you ask me a question, at least I'll get to the point of your question. That may be closer to the point than any freaking point that I think I'm going to get to. So please don't not ask the questions because you're afraid they're going to slow me down. They're probably more important than what I'm doing. Like really. But okay, I'm going to go on in the absence of questions. I'm going to go on to the next. So part B. All right. So part B. Right. Okay. So I'm even going to say like, see above for givens. Like you could totally do that. And in this case, above means the prior page, but whatever. All right. T equals. But now there's more given. Oh, okay. This is interesting, right? So by the way, one thing I failed to do, actually, I totally failed. I take 2 points off myself here because you know what I failed to do? That in the beginning, when I put the givens down, I should have put a diagram. And shame on me. Why didn't I put a diagram? Because I didn't see one on the page of the test. That is the most common and most understandable, but most wrong reason to not put a diagram. Like seriously, shame on me. I'm moving back the page. I should have put a diagram of some kind. And when I say shame on me, I don't really mean that. I don't like really believe in shame, not on purpose anyway. But what I really do mean is if you don't see a diagram on the page of the questions, that's all the more reason that we need you to give us a diagram in your answers. Like really, like what? So we need, I should have done something like this. In fact, I'll even. if I ever, someone's here, sorry. If I ever want to draw a wave or a diagram of a wave situation, I honestly think what I'm doing right now is the best. And there really should be some numbers here. Yeah. Side note, I think you should draw a diagram, like whether, especially if there isn't one. If you ever want to draw a diagram of a wave pulse, which this is, you will definitely get major points. Like one good way to show you've been paying attention and that you're really on your game is if you want to draw a quick sketch of a wave pulse, the best way to do it in a physics class is with two separate graphs like I just did. Like that would really show that you really get this equation and that you get lab 3, that if I just draw a squiggle and say, here's my wave, like that misses the whole point of what a wave is. A wave is a squiggle in space and a squiggle in time superimposed on each other, right? It's so that's my best picture of a wave right there. Now, for this question that's being asked here, whoops, it's not what I meant to do. So. Okay, just to be clear now, what this question is asking in English is like, we've got this long string, ripples are happening on the string. At any moment, if you at any moment took a snapshot of this string with the ripples that are going back and forth, like if at some moment, say 3 o'clock at t = 3, if you took a snapshot, so you're holding time constant in that moment, y would be a cosine function of x. Like you would see that snapshot picture of squiggles, right? And what we're really asking is like, if you bring your eye all the way to the right to spot x = 10 meters, like over there where we're looking, how high is the string at that point, right? That's so, so I could conversely say, okay, let's pick the spot x = 10 and take a movie of what's going on at x = 10. And that movie would be a thing going up and down and up and down. And if we made a graph, that it would be a cosine function. And we're asking at the 3rd second of that movie, how high is the dot of string? Like that would be another way you could diagram this. I think this is more direct because this is visually what you actually would see, right? Like visually at some moment, you would see a squiggle. And we're asking, if you look this far over on the squiggle, how high is the squiggle? That's what we're asking. Okay, well, how do we get that? Well, so this was all step 1, just to be as clear as I can be. This is all step 1, the diagram. And we're still assuming all the givens from the prior page. So that was like the direct chat person's question, but here's the further givens. And then step 2, diagram and fat patterns. And then step one, sorry. And then step two, what is the question? The question is, what's y? Well, how am I going to do this? I know this is a wave. Like I know, see my prior work, see my, okay, I know what by given for all this, the wave equation, again, I'm writing a little bit more than I need to right here, but the wave equation is d2y dt squared equals omega over k squared d2y dx squared, right? Like I know that, I know that. But if that's true, I'm going to the next page now. If I think you probably want to use slightly different words from the, make it personal, but I'm saying we know this wave equation up here that I just wrote. A solution to that, the wave equation is a differential equation. A solution to that differential equation is this y equals a cosine omega t plus kx. Now I might in a minute, or depending on my time, I might show you why. Probably in a minute, probably. I'm going to remind you why. I'll do a proof for you. Probably it would be great for you to show that you understand that and do that here. Okay, technically I'm going to strongly recommend that you do, that you show why this cosine thing follows from this wave equation, or why it follows from this wave equation. Again, I'll show you in a minute, or I'll remind you. But for the moment, I'm saying whether or not we show why it's true, it is true. Y equals a cosine omega t plus kx. What does that do for us? Well, that's what we need to plug in here. Like that's, we have this differential equation that describes the whole wave motion holistically. Just like we had Hooke's law that describes a mass on a spring holistically. With Hooke's law, the differential equation, we had to find a solution to it. We had to find an equation of motion. We had to find that cosine thing so that we could literally directly predict, okay, for any given time, where is the mass, right? We had d2x sorry, we had a differential equation, and then we solved it and got x equals a cosine omega t, so that we could do the normal, direct, explicit physics thing of saying, if you tell me the time, I could tell you where the mass is. Similarly here, we have this differential equation that describes how bumps on the wave become unbumped. But that doesn't actually tell you where anything is in the wave at any given time. It doesn't answer the direct question of, given some moment in time and some horizontal position, how high is the medium, right? Which is the question being asked here. What we need for that is a solution. We need this cosine expression. Now, I'll show you again in 2 minutes where I got it from, but assuming we have it, this is the thing to plug into to get the answer to question B. Like, we're solving for y. A was given as the amplitude. I'm going back to the given to you. The amplitude was given as 5 cosine. Omega, we don't know at the moment, but t is given as 3. K was given as 0.1. And x was given as 10. Right? So this is the thing that I am probably going to plug in. Well, this is the thing that I'm going to plug into. I'm going to plug in all the known values and solve for y. I think that's what it's asking. Yeah, how high or low on the oscillation y axis? How low? Oh, that's sort of badly phrased. You might change it. Sorry, I'm looking at the question right now. The question says, the question B that I'm trying to answer says, how high or low on the oscillation y-axis is this particle? Like, that is the correct question. That is the question, but it's trying to say how high or low. I could see why it's phrased so awkwardly. It's asking what's the y value, how high or low on the axis of oscillation, as opposed to the axis of propagation, which is the x-axis. Okay, whatever that's worth. So I'm solving for y. I'm about to be there. I just have to plug in values and I get y. The only problem is, the only problem is, we don't know omega. We don't know omega. Now, that's not an accident. That's what makes this question sort of tricky. Yeah, that's what makes this question slightly challenging. It's not a trick question. And let me caution you, please, again, if I were taking an exam right now, and I do realize we have 20 minutes left. If I were taking an exam right now and I got to this step, like, I'd be trucking along and be like, okay, he's giving me T. He's giving me X. I'm solving for Y. So I think I'll do like the Y equals cosine thing. Like, that sounds reasonable because it has a T and an X in it and it spits out Y. That seems like a reasonable thing to do. So I'd start writing. And then I get to this moment like, oh crap, I don't have omega. Now, I don't know about you, but if I'm me taking an exam, especially if it were like timed and it were stressful and I was trying not to cheat, I might in that moment go, oh crap. I would definitely go, oh crap, I don't have omega. I mean, I think we all would. Then, because I'm a panic case, I might very well go, oh, wait a second, I've got 2 unknowns. I've only got 1 equation. Like, I thought I was just solving for y, but I don't have omega. Oh, I must be doing something wrong. Darn it. And I get frustrated. And I would start erasing this stuff or blotting it out or obliterating it so no one could ever see my humanity. Or then I would start backtracking and looking for some other equation. Let me first just tell you, please, as a word of advice, I know you're not going to be a panic case like me, because first of all, I'm the biggest panic case in the room. Second of all, I know you're not taking this test under time conditions and all that. So hopefully you'll be calmer and you won't freak out like that. But just still, when you get to this moment and you're missing more information than you expected, or you have less information than you expected, don't think that that means that you're doing anything wrong. Like, and be very, very consciously aware of the possibility that you might unconsciously think you're wrong. One of the reasons that people will get to a thing like this, and let me be even more honest about test taking and science and all that stuff. It's totally plausible if you're a smart person, which you are, and especially if you're a calmer person than I am, you might have sat down to start this problem. But before you even started writing anything, part of your brain might have been even smart enough to kind of see down the road that you were going to be missing two things, like instead of just missing one. And so part of your brain might have just rejected that and gone, oh, wait, well, if I do that, then there won't be no, like you might have thought a cosine thing. Oh, but then I won't have omega. Oh, fuck that. And then you might not have even have started because you'd be like, oh, wait, that's not even going to work. And then you might say a thing to yourself like, I have no idea. Right? That's what people do. Honestly, that's what we all do is like, oh, I have no idea. And then like panic or talk to someone else. Something. But I really want to encourage you all to realize like that's almost never true. What generally happens with smart people in a science class like this is when they say they have no idea what to do, what they really mean is they have a lot of ideas in their head and they've tracked them so fast and they've pursued the ideas so fast that they kind of see where the ideas run out of steam or seemingly, or see where there's something that seems wrong. So instead of saying, I've got too many ideas, or saying, oh, my ideas aren't totally working out in my head the way I was hoping, life isn't going to be as easy as I hope, they say, oh, I have no idea. No, no, not the case. You have too many ideas and there's too many in your head. You must write them down. Like you must be willing to write ideas down before you see the end of the road and let some of the writing do the work for you. So what I'm getting at is I get to this step here and I'm like, oh, I don't have omega. Okay, all the work I just did to write down is not wrong. It's a good thing I wrote it down. I just have to go further now. I've got to find omega. Even if there's even a part of my brain that now thinks, ooh, I should have found omega first. So what? Like, I really shouldn't have actually, but even if you're thinking it would have been more like, so what? I didn't find omega first. I'm going to find omega now, and I'm going to put it in for whatever it's worth. So I am. So this is like, you could say this is like a sub problem or a sidebar or whatever. Maybe it's something that you would have liked to have done first. And maybe, by the way, this is a rough draft to your exam. So maybe after you're done with this and you like it better a different way, you make a final copy where you copy this in a different order. God bless it. Quark bless America. But the point is, please don't ever think that just because you're not done, that means that what you've done was stupid. Like, no. All right, so I'm going to. Hello. This is also why we wrote all this stuff at the beginning to help us. Like V equals omega times K, right? And omega, therefore, equals V times K. And we know right? The key point here is that we actually know from the original given that private chat person had us write at the beginning of the top of the whole page of this. From the original given, what I really know that hasn't come up yet, but I know is that V equals 30, right? Because V squared equals 900. That is actually a given if I understand how to read the given. The given told me that V squared is 900. So V is 30. Therefore, and K, we were told, yeah, K is 0.1 radians per meter. Okay, go to the next page. Oh, I'll go back to that page in a second if anybody fact, I'll be shocked if no one knows. Let me just write this before I forget. I forgot. That was a siren in a Walmart. I will go back to the page in a second. I promise. Well, certainly if anybody asks, I will. Right. Let me just look in the chat. Does anybody want me to go there? Yes. Chat. Okay. Sorry. Wait. Okay. So there's funny things in the direct chat. Sorry. Yeah. Wait. Oh. Okay. Wait. Wait, okay. One funny thing in the direct chat that I appreciate, and okay, and okay, wait, and there's a good question in the chat. Let me try. Look at the time. Okay. Oh, okay. No. All right. No. There was a legitimate question in the chat. It was not a dumb question, but the person who just took it back just did the thing I'm warning against. Like a person just asked. So someone said something funny in the chat that indicated that they could relate to the panic thing that I was just describing. And look, and honestly, and I appreciate it. I hope you do find this relatable, because of what I'm here to tell you all. Obviously, I'm being dramatic and I'm sort of joking and stuff. But I mean, I'm not joking about, I'm definitely not joking about what would happen to me. And I'm here, and I hope it's not a waste of your time, but one of my messages to all of you guys is like, I love my job. What does that have to do with anything? No, I love my job. I'm really fortunate to have my job. I love thinking about it, talking about physics, and I love thinking about it, talking about it like in this job that I'm very lucky to have. And it's like the kind of job that I actually wouldn't have dared dream about if you asked me like years before. But I have this job, and what I want you to know is you can be a panic case and still get a job like this. But I'm telling you how to work your way through that. Okay, I mean, I'm saying like you don't have to be a panic case, but I'm telling you that don't panic about being a panic case. Don't let it make you think that you're missing something that the rest of the world gets or something like that. You just might be missing like a mental strategy for how to calm down. But like, okay, like, but anyway, you get my point. Like, I hope you can find this relatable, and I hope it gives you some confidence or some reason to believe that you're still in the game, even if you personally, whoever you are, think you're a little bit of a mess. Believe me, I'm a mess. Right. And I wish I weren't, but like, and I'm less of one now, or certainly when it comes to this material, but like, whatever. But another person put something in the direct chat, but it makes me feel less of a mess that other people in the world can relate to. So thank you for telling me if you can relate. But then another person put something in the chat that was like a really good question. It was a really good question. And the answer, I'm not going to read it, but the answer to it happened to have been like, no. Then the person figured it out, which is great. They figured it out before I even got to it. And they were like, and I know they figured it out. And they were like, oh, they realized that the answer to their question was no. But then they wrote like, oh, forget that, I'm a dummy, or something like that. Like, and I know that was a joke. I totally know that person doesn't actually think that person actually is a dummy. But like again, and I don't want to waste all your time, but I just want you guys to notice like what we all do in hard things like physics. Physics is hard. But whenever we get it, instead of being like, whoa, that's cool, and I'm cool for getting it. Whenever we get it, we're like, well, yeah, duh, that's obvious. And then we don't get it, we're like, oh, or if we suddenly get it and realize we didn't get it a minute ago, instead of being like, whoa, I just grew and the material just got more interesting, we're like, oh, I'm an idiot. We all do that. But really, like, that's actually totally relatable, but totally like, no. You want to not have that habit when you're taking an exam. Okay, I'm getting too far afield, but just because a person asks a question and then the answer turns out to be no, it still means that question was incredibly constructive that they asked it. It's still pushing them forward. It wasn't idiotic to not, that's like regretting that you were ever 5 years old. Like, oh, remember when I couldn't walk? Oh, God, I was so moronic. Now I can walk. What an idiot that I couldn't walk. Like, no, you couldn't walk, and then you taught yourself how to walk. How amazing is that? How the frick did you do that? You taught yourself how to walk. How about that? Like, can you believe like one time I didn't know how to walk, and then next thing I knew how to walk. Amazing. Anyway, okay. So back to this thing. My actual real message is, I'll tell you this. Here's a profound point. I'm dead serious, but I'm getting quiet, so you know I'm serious. if you think about it, the opposite of true is false. The opposite of false is true, right? So any false piece of information is information if you just put the word not in front of it, right? So what that means is, think about this. Knowing something true, but not knowing whether it's true or false, like saying an answer that's right, but not knowing whether it's right or not, is far less valuable than saying an answer that you know is wrong, right? A falsehood that you know is false is far more a valuable truth than a truth that you don't know whether it's true or false. So every time you realize that you're wrong about something, you're literally realizing something super concrete and super more reliable than when you think you're realizing things, but you're not actually sure if you, right? A known falsehood is a truth. A unknown truth is not a useful truth. I'm just saying. Now back to this problem, which at least we want to finish this before the end of the hoobida-dee-bida. All right, so now I have omega. Omega is 3 radians per second. Oh, please note, omega is 3 radians per second. Literally, it's 3 radians per second. It's not pi radians per second. It's not 2 pi radians per second. It's 3 radians per second. Is that okay? Yes, that's okay. There's a such thing as 3 radians. Not all radians have to have pi's in them. It's just that if it were pi radians, we would know it's exactly half a cycle. It's 3 radians. So it's a little bit less than pi radians. So it's a little bit less than half a cycle. That's all that means. But please don't think that radians like always have to have pi's in them or something like that. And don't think that pi is some weirdo thing. It's just a number that's a little bit more than 3. And 3 is a number that's a little bit less than pi. That's all. So our omega is 3 radians per second. So now let's bring this thing home and say like, therefore, okay, y equals, well, we're plugging back into this thing and then we'll be done with this whole yada, yada, yada. So y equals, I think 5. I better put, we have 6 minutes. Okay, so we'll at least finish this problem. All right. Oh, yika. 5 cosine. So now we said omega, 3 times t. T was a 3. And then k was 0.1 and x was given as 4, I think, or 10. Right, so now we have all, so y equals 5 cosine 9 plus 1. So y equals 5 cosine 10. Is that even a thing? Cosine of 10 what? Yeah, cosine of 10 radians, which is like, you know, like more than 720 degrees, whatever. Oh, and I'm about to plug that into my phone. That's useful. So we're going to plug in cosine of 10 on our calculator. I'm like walking away to my calculator and I'm singing about it, but I totally cannot find my calculator because I'm a loser. Hold on, and we only have 4 minutes left, so I'm causing a disaster. And if you're thinking, oh, he can't do cosine of 10 in his head, what a jerk. Well, I guess if I have to, cosine of 10 is like, I guess it's like cosine. Okay, I'm going to round because I don't have a calculator. If you have one, oh, I guess I do have a computer. But basically, it's like cosine, like it's like cosine of like 3 pi. So it's like, so it's basically, oh, it's close to 0. It's darn close to 0, I think, but we'll do it exactly. So this answer may be close to 0, and that's fine. That's a legitimate answer if it's, but I think it's going to be very close to 0. Let's see. But I'm about to plug into a calculator so I don't freak anybody out. But I'm going to plug into a calculator that's in radian mode for sure. And I would here, if I'm in degree mode by accident, I'm going to get something wrong and I will take off, not huge, but I will take off points on the test because it will be. So the oh, I was totally, good thing I plugged in. Cosine of 10 is not 0. Why am I jerk face? Okay, so I think why. And this is in meters because the 5 was in meters and the cosine is in nothings. So this is my answer. And I know we have 4 minutes. Stop me if I just made a computation error. Maybe I did. Wait. Oh, thank you. Oh, thank you. I should have. That's fun. Oh, sorry. I missed a lot in the chat here. No. Okay. I'm ignoring the jokes for a second because we have 4 minutes, but wait, there's things happening. If I cancel the rating with the unit for omega, I'll speak. Oh, yes. No, that's great. That's great. Okay. Huishi's chat question. What you say, if you cancel the radian, would the unit for omega also be like seconds to the -1, 1/seconds? Yes, that brings full circle to the direct chat question from earlier. Yes, technically speaking, the units for omega, like I always write them as radians per second, just like as a placeholder that I can see, but you absolutely can just write them as seconds to the -1. And technically, yes, absolutely. And people do. So that's great. And then thank you, Gabrielle, for putting in the -4.2. I didn't see that, but actually, at least that confirms that I'm not crazy with this. It's good. I kind of want to convert. So that's the answer. So the answer to that one is -4.2 meters. Again, because the cosine thing has no units and the amplitude did have meters. So then there's one last question to super quickly do. And that's part C. Sometime later, the part, now this is asking you to understand what this direct proportionality is all about. I'm just gonna write this question. Yeah, okay. And the answer is this. This is just asking you to, well, the answer is I'll warn you. Okay, so if the concavity, I mean, this is just understanding direct proportionality. Like it's just saying acceleration is directly proportional to concavity. So if you pick a different spot where the concavity is half, then the acceleration is half. That's all it wants you to know. I'll warn you right now with 1 minute left. I could make that question a little bit more complicated, right? Like I could ask something like, well, I couldn't make that exact question much more complicated. I mean, just also note, I mean, it's a direct proportionality. It's saying acceleration is speed squared times concavity. So I could say if you hold the acceleration constant and no, I couldn't. I'll just leave it at that. Sorry. It's just making sure that you know that acceleration is directly proportional to concavity. So if one is multiplied by 0.5, the other is multiplied by 0.5. That's the end of that story. Please feel free to chat me more questions. Sorry, well, at least we finished that one. I think the questions that you did put in the chat today were great. Seriously, great, great, great. I think you guys are on a good track. I will, and I'll be in my office tomorrow morning. Thank you. Yes, have a great day. I'll be in my office tomorrow morning if anybody wants to come and ask questions. Okay, thank you. Oh, how nice. Thank you. Okay, great. Thank you, guys. Seriously, thank you. Have a great day. Okay, awesome, awesome. Ending the